Good morning and welcome back to the second lecture on gears. Let us see the symbols nomenclature of the gears. In the earlier slide we have seen different types of gears. Now we will see the various symbols, various nomenclature of different gears. Let's talk about spur and helical gears, which are used for parallel shafts. The important aspects of a gear are both mating gears should have the same module. That is very important for us. The two gears should work together if their module and pressure angle are same. Direction of rotation is different for external mating gears. As we have seen in the earlier lecture, there are gears rotate in the opposite direction, whereas internal gears rotate in the same direction. Then we see the slide here. We have got a smaller gear and a bigger gear. This smaller gear is always known as pinion. The bigger gear is always known as gear. The distance between the center of the pinion to the center of the gear is called center distance. And there is an imaginary diameter for all the gears called as pitch diameter. Pitch diameter is the imaginary diameter. Pitch circle or pitch diameter is the imaginary diameter, which will be in the middle of the gear tooth. Each one is called gear tooth, and an equal amount of space here called tooth space here. And what is important is the pitch should be same for both mating gears. Pitch is same means module is same. If you see the outside to outside full circle, outside circle here, that is called addendum circle. The inside one is called root circle. Outside circle here, outside to outside. Inside to inside is called root circle. Then there is one more circle on which the involute profile is generated is called base circle. Base circle. Very important dimension for a gear is the module. Module is a metric symbol. In the earlier inch system we were calling as diametral pitch DP gears. Now in metric system we call as module. Module is basically the ratio of pitch diameter to the number of teeth. Pitch diameter by number of teeth is the module, which we cannot really see on the gear, but this controls the entire parameters of the gear. Module is very important dimension for any gear. Indian standard has given standard modules as per IS table 2535. This table is available in our data handbook volume 2, page number 2361. Table number 23-3. There are standard modules available from 1 mm to 45 mm, and some values are given in the brackets. That value should not be used. They are second choice. To the extent possible, use values without bracket only. Then if you see, the pressure angle is another important dimension for a gear. It is the angle between, this is the common tangent of the pitch circle. See the common tangent. There are two pitch circle for the pinion, pitch circle for the gear. They are meeting at this point. If you draw a tangent here, this becomes the common tangent of the pitch circles. There is also a base circle for the pinion, base circle for the gear is here. If you draw a common tangent for the base circles, the angle between the common tangent of the pitch circles and the common tangent of the base circles is defined as the pressure angle. This is the angle along which the gear forces act. This is also called as line of action. There are three standard pressure angles recommended in the market: 14.5 degrees, 20 degree full depth involute, 20 degree stub, and 25 degrees. These are the pressure angles recommended, and Indian standard recommends only 20-degree full depth involute. 20-degree full depth involute. The other parameters for the gears are tooth thickness. The thickness from on the pitch circle from beginning of the tooth to the end of the tooth, the horizontal distance is called the tooth thickness. Here you can see that there is a pitch circle here. This red line is the pitch circle here. The distance measured from one tooth to the end of the tooth, this thickness is called tooth thickness measured on the pitch circle, and circular pitch is the distance from one point of one tooth to the similar point of the next tooth. Distance between two consecutive teeth measured on the pitch circle is called the circular pitch, called as pitch here. This is the starting point of the tooth and next tooth starting point. The distance from here to here, the circular distance, is called circular pitch or generally pitch. Addendum is the distance from the pitch circle to the outside diameter. The height from pitch circle to the outside diameter circle, the height is called addendum. From the pitch circle to the root is called dedendum. The pitch circle is always the reference circle for all the dimensions. Pitch is measured on the pitch circle. Height of addendum is measured from pitch circle to outside diameter. Dedendum height is measured from pitch circle to the root of the gear. This is called addendum and dedendum. Addition of addendum and dedendum is the total whole depth of the tooth. Depth of the tooth is addendum plus dedendum. Then clearance. Any gear will have clearance because addendum should not dig onto the dedendum of the mating gear. The distance from the addendum of one gear to the dedendum of the mating gear is called the clearance. A small value is left here, is the clearance here. It is the distance from the addendum of gear to the dedendum of the other gear. Here is the clearance. Tooth depth, as I told you, it is the total height of the tooth. Face width is the thickness of the gear measured along the axis. This is the width of the gear, is called face width. Pitch lane velocity is also called as velocity of gears. The gears are circular members rotating. So any rotating member, the velocity is given by pi dn by 60,000 or 6,000 or 1,000 depending on the units we are looking for. We put 60,000, pi dn by 60,000. That is the pitch lane velocity of the gears. Then pitch circle is an imaginary circle on a gear which will be helping us to have pure rolling. Two mating gears of this diameter, circular discs, friction discs, which will roll on each other and give you the same ratio, are called pitch circle. This is an imaginary circle on the gear or pinion. It is equal to module into number of teeth. Then comes to addendum or outside circle. If you see this figure here, from the pitch circle to outside is addendum in one side. Similarly, other side also we will have one more addendum. So addendum diameter is nothing but the pitch diameter plus one addendum at the top, one addendum at the bottom, two addendums. Similarly, dedendum diameter is d suffix f, small f, is the pitch circle diameter minus one dedendum in one side. The opposite side also one dedendum. So the dedendum circle diameter is df equal to d minus 2h. hf. Addendum dia is d plus 2ha. Dedendum dia is d minus 2hf. Helical gears, the teeth are not parallel to the axis like spur gear. They are inclined to the axis, and if you keep your left hand like this and it aligns, the thumb aligns with the tooth, then it's called as left hand helix. and if the tooth aligns to right hand thumb, it's called right hand helix. Helical gears have the teeth inclined to the axis. The angle of inclination is called as helix angle. Then we have two types of helix, right hand helix, left hand helix, and there are two sections for the gear, helical gear. One section, if you take along perpendicular to the axis, this is the axis of the gear. If you take perpendicular to the axis, this section is called as transverse section. When you take a section perpendicular to the tooth, this is the tooth here. For the tooth, if you take a section perpendicular to it, this is called normal section. And all gear parameters are true size in normal plane only. You have standard module, standard pressure angle, all are valid in the normal plane, not in the transverse plane. The difference between normal and transverse is normal pitch equal to transverse pitch into cos beta. If you see here, cos beta equal to Pn by Pt. Hence, module also will be transverse module equal to normal module by cos beta. Mt equal to Mn by cos beta. Then comes your normal module. You can see here very clearly we have got a perpendicular line to the tooth, that is called as helix angle, transverse pitch, helix angle here, normal pitch equal to Pt into cos beta, or Mn equal to Mt cos beta. Then center distance, the distance from the center of the pinion to the center of the gear. This is denoted by small a. Small a is center distance. It is nothing but radius of the pinion plus radius of the gear. R1 plus R2 is nothing but D1 plus D2 by 2. D1 plus D2 by 2. Whereas for helical gear, it is Mn Z1 plus Z2 by 2 cos beta. Helical gear, you have to divide this by cos beta. Thank you. These are the major symbols we are using in the gears, nomenclature of gears.